All right, we're on.
Okay. Hi, my name is Max Chaplin,
And I'm Willie Bowman.
and this is our final Joust game presentation.
We're going to start off by talking about some extra features that we had, the first of which is a home screen. You can see the first thing is a text area that displays the controls, monsters, and the scoring system. And there's also a play Joust button, big and red. And so the game doesn't actually start until the user presses that button. And we also have a feature on the home screen that allows the user to play around with the controls a little bit for the hero. You can see on the right there, the red rectangle is the hero, and so the user can play around with the controls and move them around before the game actually starts. It's a nice feature. And now we'll go on to the next extra.
So our next extra is called the turret. And so this is a third type of monster in addition to the regular monster and shooting monster. And turrets shoot in all four directions, as the functionality is shown there on the right. And they shoot bullets every 1.5 seconds. And if you remember on the last slide on the home screen that Willie explained, it was not on the home screen directions, as it's a surprise only found in the bonus level, which we'll get to in a minute. So next, we added the player getting multiple lives. So this first video shows a player being allowed to get hit by a bullet once, but not dying. So they remain alive. And then this next video is similar. It shows the player getting hit once and not dying, but turning into its ghost self, meaning it has only one life left. And then it gets a monster's egg to get the life back, and then it's back to 2 lives. And then the last video shows the hero getting hit 2 times with a bullet, causing the game to be over. And also, every time you get hit with a bullet, it is minus 10 points to your score.
The next feature that we'll talk about is our bonus level, which is a 4th level after the 3 normal levels. And so the bonus level is only reached if the user gets a perfect score of 1,000 during the first 3 levels, which is pretty hard to do, we found out. So we'll demo what that looks like now. And so you can see the hero is going to go up on the 3rd level here and kill the last monster remaining and get its egg, and then prompt the user to press B for the bonus level. Once he does that, he's taken to the bonus level, which has the turrets.
So the next extra is the restart key. So this basically, the user can press the R key at any point to start their game over. So this first clip shows the user pressing R when they die. And again, it's prompted when the player dies. Press R to restart. And then the next clip is similar. It shows the player pressing the R key after they beat all the levels. So this is the end of the 3rd level, and they won, and they press R to play again. And when you hit R, your score restarts at 0.
The last extra feature that we added was the grass on the platforms. This just adds to the overall colorful theme of the game and adds a bit of realism to a game that is not at all realistic.
So next, for our overall design, the biggest thing we wanted to point out was that we used an abstract class, which is a type of inheritance for the player class. So inheritance was a topic that was a struggle for me individually in this class, but having time to work through this project, using this concept consistently, made it much more clear. And so a lot of duplicated methods within all of the included classes on that second bullet basically just really relieved the duplicated code and it just made sense to use inheritance there to increase efficiency. And also another bonus we didn't really know we were getting ourselves into, but when we added our 3rd type of monster, the turret, it made that a lot easier, because the implementation was steps we'd already taken when we made the regular monster and shooting monster classes. So we knew how to write the code, we knew how to implement everything, so it wasn't super difficult for us to do that.
And now we'll take a look at our before and after UML diagrams. You can see there's quite a big of a difference between the two. We knew that our design wouldn't actually follow our first UML that closely, but we didn't think it would be this drastic. You can see in our final UML, we ended up having a lot more classes. We ended up with about 17, and so all of them aren't even shown in that UML. You can see there's arrows going everywhere. There's dependencies, there's a lot of inheritance with all the classes inheriting from player. So it was pretty crazy, and you can see how much plans can change over the course of designing a program. And lastly, we'll talk about the tricky bug before we talk about some things that we could do better. And so the trickiest bug that we had took us about 2 hours to figure out, and it was early on. It was handling collisions between the hero and the platform, and we were running into trouble with the hero teleporting through platforms or going on the wrong side of platforms. If they hit the bottom, they would be teleported to the top or something like that. And that was because we were just trying to use the intersects method between rectangles, which did not work at all, because we wanted to handle collisions with the top of a platform differently than with the bottom of the platform. And so we tried some different things to fix this. We tried putting lines on the top and bottom of each platform and saying when the hero intersects the top line, do something. When they intersect the bottom line, do something different. That didn't work either. The intersect line method didn't work how we thought it would. So we ended up going with a solution that basically just put rectangles on the top, like rectangles with thickness, on the top and bottom of each platform. So we could say when the hero hits the top of a platform, it stays on the top. When it hits the bottom, it stays on the bottom. And that worked really well and allowed the game to be a lot more smooth, because we also shortened our timer delay to 1 millisecond, which made the game much more smooth in handling collisions. And it also allowed us to add grass to the top of platforms, and it made it very easy to do that because the rectangle was already there. So all we had to do was fill them green and then draw them.
Then the last thing we wanted to go over was areas of improvement. If we ever wanted to remake a game similar to this, just kind of the approach we'd have and what would change potentially. So overall, we obviously made this program completely functional, plus all the extras, with solid design, as many of our object-oriented design principles were followed as much as possible. But after we reflected and talked about it, if we had to change anything, we decided our cohesion could have been brushed up a bit. We could have used the main class more, or other classes, which would have made the game panel class less of a super godlike class. And then another critique looking back would have been to clean up the coupling. When we made our final UML, after all our code was done, we saw that there was some unnecessary arrows and dependencies. Also, while we were writing the code, we realized there were a few git chains, which is another indicator of high coupling. So overall, just splitting responsibilities into the main class or other necessary classes would significantly help our design principles, since it would take a lot of emphasis off of the game panel class, which is our largest class with the most methods.
And this concludes our presentation of Joust. We had a lot of fun making this game, and we made a pretty cool game that we'll be playing a lot in the near future. Thanks for watching.
Thank you.